Okay, we are back. Let me get back to this. So, last video I talked about pure substances, elements, and compounds are the first two of them, or the only two of them. And then I started talking about mixtures, specifically homogeneous mixtures, which is this. So, they're mixtures that look the same throughout, and I talked about solutions. Now I'm going to actually skip through the rest of this because we went over it already, because the second homogeneous mixture is a colloid. Colloids are homogeneous, but their particles are bigger. Their particle size ranges from greater than 2 nanometers to less than 500 nanometers, but you don't need to know those numbers, it's just a reference again. The particles don't settle, so they stay suspended throughout. Well, I don't like using that word suspended for a reason, but they stay evenly distributed throughout. The particles do scatter light. That means that if you shine a light through it, it won't go through all the way. Okay? Examples of colloids: milk, mayonnaise, jello, whipped cream. There are 3 different types of colloids: aerosols, which is a solid or liquid particles in a gas, smoke, hairspray, fog. Those are aerosols. Anything that is somewhat dissolved in a gas, but the particles are too big to be a solution. Emulsions, liquid in a liquid, that's a mayo, like a mayo. Mayonnaise, I mean. Mayonnaise is egg in oil. You mix it up and it's an emulsion. And gels are also a type of colloid. It's liquids in a solid, and that's because when you make jello, you have the solid powder and liquid, so the liquid gets suspended throughout the solid. Okay, and any other gel like hair gel and things like that. Let's move on. The next type of mixture is the opposite of homogeneous, and that is heterogeneous or heterogeneous, however you want to spell it or say it. I accept both pronunciations. In a heterogeneous mixture, you don't see an evenly distributed mixture, so you can tell the different parts. A salad, for example, would be a heterogeneous mixture. You could see the lettuce, you could see the tomatoes, you could see the onions or whatever else is in your salad. So that's what makes it heterogeneous. And for my engineering tech people, a burrito bowl is a heterogeneous mixture. Suspensions are a type of heterogeneous mixture. So a suspension is a mixture whose particles are, I don't know why that's there, mixture whose particles are dispersed in a liquid or a gas and will eventually settle. So take a second, I want you to think about it. What are some things that you can think of that are suspended, I guess you could say, in a liquid or a gas and then eventually settle? Just take a second to think about that. And write it down as some examples. I'll have some examples here too. All right, the particles in a suspension are large, greater than 500 nanometers. They can scatter light. They eventually settle. Since they are so large, they can be filtered out as well. So some examples are a snow globe, sand in a bucket of water, and muddy water. So if you go to the beach, probably don't do this that much anymore, but when you're little, went to the beach, you go into the ocean to get some water for your sand castles, and when you get back, the water is still kind of cloudy. If you let it sit, the sand will settle on the bottom and the water is on top. So just a review of the 3 types of mixtures we went over: the 2 homogeneous ones and the heterogeneous in the middle. Okay, so solution, this is the one with the smallest particles. Light behavior, it does not scatter light. That means that light will go straight through it. And particle behavior, the particles do not settle and they can't be filtered. A suspension, this is the opposite of not the opposite, but the furthest from a solution, the largest particles. Light behavior, it's scattered, meaning that the light does not pass through, and the particles settle and can be filtered. And finally, the colloid. Colloid scatters light like a solution, but the particles are, it scatters light like a suspension because the particles are bigger, but the particles are not big enough to settle and cannot be filtered. Okay? So how do we separate mixtures? There's several different ways. Certain ones we're going to be using in class. Chromatography, this is separating different dyes from one another by their individual densities. So different colors have different densities, and different colors are made up of other colors. So we will be trying that in class. I have chromatography paper, and we'll be doing that tomorrow in class. Filtering, exactly what it is. You use a barrier to separate the large particles. So you can use like a strainer or a pasta colander, or you can use a coffee filter. Distilling, and a lot of you asked about distilling or brought up the term distilling when we were going over the substances. We had distilled white vinegar and distilled water. Distilling is a process where you boil away one substance from another. It only works if the substances have large differences in boiling points. So salt water, for example. That works because salt does not boil at such a low temperature compared to water. Water boils very low compared to salt. So you can boil the water away and the salt is left behind. Last is a centrifuge. Centrifuge is a machine that you put certain substances in. It'll spin those substances, and as it spins it, it separates them, and then they are layered by their density, the most dense on the bottom, least dense on the top. Centrifuge, we will not be using that in class. It's a rather expensive big machine that I don't have. Okay. Would chromatography have been a useful way to separate the mixture of dirty water? These are actually lab questions that I'll go back to because we're going to be doing a lab. Okay? So, this is your activity that I want to be done, regardless of whether you get it done in class. I'm checking it for homework along with the notes. So, you have 3 things that you need to classify these as: element, compound, and mixture. I'm not expecting you to break down the mixture into homogeneous or heterogeneous, but as an added that's something that you can do to show me that you really take things seriously. And yeah, that's if you can put down heterogeneous or homogeneous, then it shows me that you have a very good understanding of the material, and I'll be rather impressed. Okay, so I will now click through. I'm not going to say anything. I'm just going to take about a few seconds on each slide, write down the substance, and write down what you believe it is: element, compound, or mixture. Okay. There are about, I think there's 15 things. Let me pause and I will count exactly how many there are. So when I said 15, I was pretty close. There's actually 14 of them. So if you want to number it 1 through 14, you can make a table 1 through 14 and then make columns of element, compound, mixture, and then check off which one is which. Okay? So for number 1, our first substance, rocks. Next substance, copper. Next substance, jelly beans. And not just the jelly bean itself, but this collective of jelly beans. Next, table sugar. Next, diamond. Next, tea. Next, salt. Next, neon or neon gas. Next, salad. Next, pure water or distilled water. Next, aluminum. Next, lemonade. Next, silver. Next, sand. Next. All right, that would be it. So this is not something you have to copy, but it's just something that you can see. If you have something that's matter and it has a variable composition, meaning it changes its composition, not exactly the same throughout, then it's a mixture. If it's all the same stuff, made of all the same particles, it's a pure substance. And then is it separable into simpler substances? If not, you have an element like helium. If it can be, you have a compound like water. And the only way compounds can be separated is by chemical means. So if it is not all the same stuff throughout, not a pure substance, you have a mixture. If it looks the same throughout, it's homogeneous, like tea. If it does not look the same throughout, it's heterogeneous, like wet sand. All right, that is everything, guys, and I will see you later. Good job. Bye.